Hi, I'm Han Byun,
I'm Robin Huang.
I'm Lena Perry.
And I'm Michael Edwards.
and we are Team 25, and this is our final project, Co-Parent. Co-Parent is a web-based application designed to help divorced or separated parents manage shared custody in a more structured, neutral, and accountable way. Right now, most co-parenting coordination happens through informal tools like texting, email, phone calls, or shared notes. While these tools are convenient, they often lead to miscommunication, lack of clear records, and escalation during disagreements. For example, something as simple as rescheduling a custody day can turn into confusion about who agreed to what, when, and why. There are existing apps in this space, but many of them still rely heavily on messaging or attempt to act as mediators. This introduces two major issues. Communication can still be ambiguous or emotionally charged, and the system itself can be misused or misunderstood. Our approach is different. Instead of focusing on communication, co-parent focuses on structured coordination. The platform acts as a neutral system of record where custody schedules are clearly defined, changes require explicit agreement from both parents, and every action is tracked and recorded. The core idea is to reduce ambiguity and conflict by enforcing clarity, accountability, and mutual consent. In this demo, we'll walk through a full user scenario from the perspective of our primary persona, demonstrate the key features of the system in its final implementation, explain the technical architecture behind it, and discuss some of the major challenges we faced during development and how we address them. We begin on the login page. The user enters their email and password. For this demo, we're using predefined accounts representing each parent with their custody schedules already in place. When the user submits the form, the front end sends a post request to our backend authentication route. The backend validates credentials and generates a session token, and that token is returned and stored in local storage. This token is then used to authenticate all future requests. After login, the user is redirected to the dashboard. On the dashboard, the user is greeted by their display name, and they are presented with three primary actions: the calendar, the expense log, and the audit log. The goal here is simplicity. We want users to immediately understand what they can do without navigating through complex menus.
Next, we move to the calendar, which is the core of our application. Here, users see a full monthly view of the custody schedule. Each day is assigned to one parent, and this data is dynamically loaded from the backend. The key feature here is not just viewing the schedule, but managing changes in a structured way. So, let's say parent 1 needs to adjust a custody day. They will first click Propose Swap, and then from there, they will click on a specific date. So let's say they want to switch Friday the 3rd for Friday the 4th. Now, they can confirm the swap and enter a reason for why they need to do the swap. So let's say parent 1 has a work trip that they need to get the other parent to approve. So then they can submit the swap and a prompt pops up telling them that it was successfully proposed. Importantly, the calendar does not update yet. The change is only proposed, and you can see that what the dates are that are being swapped, the reason for the swap, and the parent can cancel at any time they wish. So if we switch over to parents to perspective, they will log in, head to the calendar, and they will see that the other parent requested a swap for April 3rd for April 4th because they have a work trip. Then they can choose to either accept or reject. If the other parent accepts the swap, then the dates will swap and it will be logged on the audit log and reflect in the UI. If they reject it, no change is made, the request is marked as rejected, and you will also see in the audit log that it was rejected for the swap. So here, let's say parent 2 accepts. They will get an update saying that the swap was accepted, and the days will update showing that Melissa now has custody on Friday, where Michael has custody on Saturday. This ensures that all changes are explicit, traceable, and mutually agreed upon, which is the core value of the system.
Next is the expense log. The expense log allows users to share logged expenses, view past expenses, and track who paid and who owes. Each expense is structured as a record rather than a message, which reduces ambiguity and makes financial tracking much clearer. We can see here there's category, payee, amount, split, and date stored with each expense. Next, we can go to the audit log. The audit log records all important system actions, including logins, schedule changes, approvals, and rejections. So we can see a couple from the calendar swap that was proposed and accepted earlier in the and each entry includes the action, the user who performed it, and a timestamp. This provides full transparency and creates a reliable history of interactions.
I'll now walk through the technical architecture of our system and how everything fits together. At a high level, our application is built as a full stack web app. The front end is developed using HTML, CSS, and JavaScript, and the back end is built with Node.js using the Express framework. These two layers communicate through REST API calls, which allow us to keep the front end and back end loosely coupled and scalable. Starting with the front end, its main role is to handle everything the user interacts with. It's responsible for rendering the UI, capturing user input, and making API requests to the backend. For example, when a user views their calendar or submits a change request, the front end sends a request to the backend and then updates the UI based on the response. This separation allows us to keep the front end focused purely on user experience and presentation. On the backend side, we handle all of the core functionality of the application. This includes business logic, authentication, data validation, and overall state management. The backend essentially acts as the brain of the system, ensuring that all of our operations are processed correctly and securely. To keep things organized and maintainable, we structured the backend into four main layers. The first layer is routes. Routes define the API endpoints that the front end interacts with, such as /API/auth/login, /API/calendar/events, and /API/calendar/change requests. Each route is responsible for receiving an incoming request and passing it to the appropriate service. Routes themselves stay relatively lightweight, which helps keep the code clean and easy to follow. The second layer is services, which is where the core logic of the application lives. This is one of the most important parts of our architecture. Services handle the actual operations behind each feature. For instance, in our calendar service, we have functions like list events, which retrieves all events for a given household, propose change, which validates and creates a change request, and respond to change, which updates the status of a request and applies the corresponding changes if approved. By centralizing logic in services, we make the system more modular, easy to debug, and easier to extend in the future. The third layer is middleware. Middleware sits between the incoming request and the route handler, and we use it primarily for authentication and error handling. Our authentication middleware works by extracting a token from the request, validating it against stored session data, and then attaching the authenticated user to the request object. This ensures that protected routes can only be accessed by authorized users. We also use middleware to standardize error handling so that the system responds consistently when something goes wrong. The fourth layer is state management. For development purposes, we use an in-memory state model. This includes data structures for users, sessions, calendar events, change requests, expenses, and audit logs. While this isn't persistent like a database, it allows us to quickly iterate and test functionality without additional setup. A key design decision here is that all data is tied to a shared household ID. This ensures that both parents in the system are always operating on the same data set, which is critical for maintaining consistency in shared calendars and expense tracking. Overall, this layered architecture helps us separate concerns clearly across the system. The front end focuses on user experience, the back end handles logic and data integrity, and within the back end, each layer has a specific responsibility. This makes sure this makes the application easier to maintain, debug, and scale as we continue adding new features potentially in the future.
The most important technical component is the change request workflow. Instead of directly editing events, users first create a proposal. The system stores this separately from the actual calendar. The other user must then approve the proposal, and then only then will the calendar be updated. This creates a controlled state transition. First it is scheduled, then it is pending, and then it's either accepted or rejected. This design prevents inconsistent states and enforces accountability on both parents.
Each page has its own JavaScript file that sends API requests, processes responses, and updates the DOM. One major challenge was ensuring consistent API paths, correct token usage, and proper data formatting between front end and back end.
To get a little bit more specific about some of the challenges and solutions we faced while we made the app, we'll go through a couple of them here. The first that we ran into is AP integration issues. We initially had mismatches between front-end requests and back-end routes. The way we solved this was by standardizing all API paths and ensuring consistent use of route prefixes such as /API/. A second challenge that we ran into is authentication bugs. So we ran into some issues where users appeared logged in, but requests failed. Our solution to that was centralized token handling and added middleware validation as we covered previously.
The third major challenge that we faced was calendar rendering. Some events were being fetched but not displayed correctly. To solve this, we built a structured month grid and mapped events by date. And then the next challenge that we faced was usability concerns. Originally, users didn't know how to initiate swaps, so the solution was we redesigned the interaction to be more intuitive and be action driven more than intuitive.
We also encountered issues with handling time zones. Since our application involves scheduling and shared calendars, inconsistencies in time representation could easily lead to confusion between users. To solve this, we standardize how dates and times are stored and processed across the system, ensuring consistency between the front end and back end. Another challenge we was dealing with duplicate swap or change requests. Without proper checks, users could submit multiple requests for the same event, which could lead to conflicts and or unintended behavior. We also ran into issues with inconsistent state updates, especially when multiple actions were happening on the same data. This could result in mismatched views between users or incorrect application state. To fix both of these issues, we introduced stricter validation checks and introduced validation logic in our services to ensure that all changes are applied in a predictable and consistent way and that we count for these specific edge cases.
In summary, co-parent provides a structured system for managing shared custody that prioritizes clarity, accountability, and mutual agreement. By replacing informal communication with controlled workflows, we reduce ambiguity and help users coordinate more effectively. This project reflects both our design goals and our implementation work across the full development cycle, from concept to a working system. Thank you for watching our demo.